generation of engineers builds the tools that expand humanity's reach. Telescopes let us see beyond our world. Compilers let us think beyond our brains. AI lets us create beyond our hands.
When astronauts went to space, they didn't just explore the new world. They explored the new laws of physics. The things they trusted, gravity, time, inertia, behaves differently up there. Now, as engineers, we are stepping into our own version of space.
Think of software engineering today as early spaceflight. We've built our first rockets. Our co-pilots, our assistants, our agents, they're powerful, unpredictable, and sometimes they blow up on the launch pad. But they're taking us to a place that we've never been before, towards intent-driven creation.
AI is reshaping the physics of software creation. What used to take us days now happens in moments. What we used to design line by line, now we describe in intent. As out in space, so there are some forces, like not everything is upended. Some things are still keep us steady.
So what happens when the old laws stop working? The way that we design, test, and learn is upended and bent by this new force. This is what we want to explore today. My name is Taraporewalla, and I'm the Thoughtworks CTO for the APAC region. Lately, I've been focused on where our industry is headed and understanding the steps that we need to take to make our future successful.
My name is Mei Xu. I'm the Regional Head of Technology for Thoughtworks APAC. So my role is actually leading the team through the changes, partner with our client, actually from strategy to execution. So today's XConf focus is all around what kind of role AI plays in software development. In the study, you are actually going to hear from our practitioners to share the state of play across design, development, and security. But in this morning's keynote, we're going to lift your eyes, looking ahead towards the horizon and thinking ahead of the direction we're going and the action what we're going to take that will help us launch this rocket in the future. We'll discuss actually a gravitational shift that is going to bending the gravity, what we call today. And we're going to actually discuss will gravity still holds. And most importantly, is around how you can shape the new gravity. The rocket has left the pad. We are already in motion. But what really is changing isn't just the tools. It's the physics of how software is created. Let's look at the new forces that are actually acting on our own craft. So when we talk about each of the new forces that is going to bend the gravity, we're going to leave you one key question for you to think about.
20 years ago, agile software delivery broke up the atoms of how we deliver software. No longer did we have long and lengthy months or years on process designing systems that would then spend another lengthy and years on years building the systems for which most of the things were wrong, broken, and it would lead to testing cycles that would have to start from the start again. Waterfall gave us the ability to break things down smaller. We could then go from design to development to test, not years, not months, but a couple of weeks. And we could start to deliver value to our customers early and often. We're seeing the same sort of fundamental disruption to the way that we deliver software with AI today. And where we're seeing the projection of the new tools, the new models that we are working with today, we're seeing it suddenly squishing and having us reimagine what software looks like today. How we can easily go from idea to impact and squash these disparate steps that we have in the way. And when we do that, we start to think about software design as two steps. Reverse engineering, which is understanding our existing systems, understanding the requirements that we need to develop, and really starting to get a hold of this ecosystems that we look after. And forward engineering, which is taking those ideas and then recreating them so that they're working software and they can start delivering value to our clients. So with this compression, we are already seeing parts of this emerge today. And today you will actually hear from our practitioners where we are, where it stands. But in the next couple of years, the world is going to look a little bit different in these two steps. We're going to start using AI-based requirements. We can start to rapidly prototype, grab our user experience, and let AI help us do a lot of the work when it comes to creating our stories, creating our requirements. We are also today able to put AI to good use to understand our systems. If your code base is small enough, you can put Claude Code or ChatGPT against your code and really interrogate it and ask it what it's doing. If it's more complicated, you might also hear today about how we've been able to look after 10,000 lines of mainframe code with some techniques, some traditional AI and generative AI techniques working together to create this state of us finally being able to understand exactly what our systems are doing. Looking forward to a forward engineering, we're starting to see the emergence of new patterns that will help us get to value to customers quicker. Coding agents that can take specifications and turn out code that works. Testing agents that validate that the code that was output by the agent is actually doing the thing that we intend. Architecture agents that have a look to make sure that the output in the system is behaving as we want it to. Deploy agents that make sure that any time we put a new change through, it is a working system that we always end up with. And finally, operations agents that look and help us run our systems, identifying problem areas before we even get up and out of bed. So when we have these two things working well together, and the industry is working rapidly towards a point where this could be a reality. A unit of work is no longer just the lines of code. It's the expression of behavior. We spend less time typing and more time thinking, curating, contextualizing, and really important, communicating what we mean and how our systems are built. Source code gives way to source specs. If you've heard about spec-driven development, we're already starting to see the first stages of this come to life, where our ADRs, our UX design, our BDRs, our epics, our stories, our features, our architecture designs, these are all becoming the source of truth, and instead of code. If that happens, what does it mean to work with systems that are built with a spec-driven way and still look after today's systems? What does it mean when our velocity outpaces our understanding? How will we manage to what we've written today with what we want to write tomorrow? Can our practices keep pace with the models as we rewrite their own rules? Velocity can't replace understanding. The real challenge isn't building faster systems. It's ensuring what we build still makes sense to the people who are responsible for it. Clarity of intent becomes the new compiler, because when speed outpaces understanding, the only gravity that keeps us grounded is human judgment.
So once innovation took years to happen, so ideas moved slowly from sketchpad to prototype to production, but not anymore. So today we're seeing the collapse of cost and time. Design, production, and delivery has been accelerated in a speed that we have never seen before. Innovation now actually moves at the speed of imagination. We have long been talking about the iron triangle of quality, cost, and time. Is that still relevant? All right. In every area of software development, one thing we're constantly working hard is to shorten the feedback loops. We learned by practicing like monitoring and improving. Like, Agile shortens that loops from like years to months to weeks. With DevOps and continuous delivery that has further compressed that feedback loop from like yearly release, quarterly release to multiple release a day, on-demand release. But AI now has made that feedback loop almost become instantaneous. So now it's actually like one thing is different is system is no longer just executing our own logic. They actually learn the behavior from the output in real time. Just zoom out. Let's look at organization level, the entire process from idea to impact. So with AI, it actually basically has touched every point from idea there. So you can see it's actually starting from idea to experiments, like to research, to POCs, to production. The entire path has been fast-tracked. Just in this afternoon, you're actually going to hear from Katie about her experience about rapid prototyping. Not only the path to production, the path to idea to impact has been shortened. Actually, the path to become legacy also has been significantly shortened. Like one of the most recent example actually comes from LangChain. Like in their most recent 1.0 release, they totally just rewrite their 3-year-old code base. Thinking about that in the past, people will choose to patch the system rather than rewrite the system, as it will take too long to rewrite and it will cost too much to rewrite. So, questions for you. What if? What if building software is no longer the bottleneck? That means all the decisions we have made with the hypothesis about building software is slow and costly, all those decisions will need to be revisited. And thinking about vendor login and ever-increasing cost of your cost system and the SaaS software, now it's an opportunity to break that loop. And thinking about the 30-year-old legacy system, no one really understands what it does do anymore, but you have to maintain it. Now it's the opportunity to modernize. Actually, when we talk about this, do we still need to maintain the software if it's easier and cheaper to just rewrite? So the bottleneck actually clearly shifts from building faster to deciding faster. So thinking about how can you redesign your organization so you can enable fast experiment tracking, enable better data-driven decision-making, and to fast-track the path from idea to impact as a first-class capability. But most importantly, thinking about how does this going to impact everyone's role.
All right, so the most important thing you need to be asking right now is, what does it mean for me? What does it mean when me, as an engineer, as a designer, as a technologist, needs to start looking and operating on these systems that build themselves? That we just have to think about what the intent of our system is. What are the skills that we need to think about. I'll argue with you that they're the same skills that you need today when you're making predictable code. Things that help us deliver value to our customers. Because software delivery has never really been about tappity-tappity, clickety-clickety of the keyboard. It's always been about how we can deliver good quality products to our customers. What we're seeing is the rise of the expert generalist, people with depth who can move between domains, but with a wide angle of understanding of the whole system. And what do they look like? They're curious. They follow threads beyond their own discipline. They're collaborative. They know when to partner with specialists. They're customer focused. They always try to engineer choices back to purpose. They value fundamentals, principles that endure as technology shifts, and they have sympathy for other domains. They understand how to design, architect, and operations shape one another. In a world of AI-generated code, these are the people who still know what good looks like. They can critique the AI's output. They can spot brittle problems and adapt suggestions to fit sound architecture. These are the people that ask better questions. That's the real skill in the age of intelligent systems. Of course, that doesn't make specialists irrelevant and obsolete. Deep expertise still matters. The magic happens when the expert generalists and specialists work together. The generalist connects the logic and the dots, the specialists sharpen the edge, and the team becomes a living organism, fluid, adaptive, learning. It matters in an AI-first era when AI changes what it means to be an engineer. We spend less time implementing, more time integrating, less time typing, more time thinking. The expert generalist becomes that human connective tissue in an AI-augmented ecosystem. They know just enough of everything to see the gaps that AI can't, the trade-offs, the ethics, and the edge cases. They're the ones who look across our systems and say, yes, AI built it, but should we deploy this? And that's the kind of thinking that we need when acceleration meets autonomy. These are 3 questions that can really help you guide on your journey. The first question that you can ask yourself is, what thinking is fundamental to my subject, to my craft, that should not be outsourced? What thinking is mechanical and can be outsourced to expedite our process, our learning? And what's the best AI tool to use it? Because what if expertise was measured by judgment and not by code volume? Are we hiring and promoting for curiosity or for comfort in our tech stacks? What does it mean to treat learning rate as a KPI? How do we grow discernment as a core engineering competency? If the old model of engineering was about gravity, staying grounded in depth, the new one is about orbit, moving between layers, connecting disciplines, seeing patterns from the above. The expert generalist is the astronaut of software engineering, not defined by one domain, but by an ability to navigate across them. Gravity still holds, even as our forces keep changing. Even as AI reshapes how we build what we build, some forces still anchor us to our craft. They're the quiet constants that keep us from drifting off into chaos, because as every astronaut learns, in zero gravity, we need new ways to orient ourselves. These are ours.
Tools age, system endure. Understand systems, not just tools, not just using AI as a hammer. Focus on the problem you're trying to solve. Understand the ecosystem. Understand the upstream and downstream impact. understands the implication for now and future, understands the impact for people for every decision you made. For different type of problems, it requires different paradigm of thinking. So AI will not be and cannot be the only solution for all the problems. The world is actually getting even more complex. The only thing that actually can anchor us today is system thinking. System thinking is the anchor to keep us, actually help us achieve global optimization over local optimization.
Words matter. 15 years ago, I coined the term cross-functional requirements so that people would stop thinking about performance, load, and other non-functional requirements with disregard. I'm seeing the same shift today. Someone on our team came up with this expression, AI in the loop, and I think it is so powerful. You've all heard about human in the loop, but that really removes us from the control and our responsibility. So the next principle that we want to talk to you about is the fact that you remain in control. AI is in the loop. Even intelligent systems must still serve human intent. So we need to keep designing our systems with human at its focus. Responsibility doesn't disappear with autonomy, it intensifies it. Responsible tech matters. It mattered the last decade, it matters even more today. Because bias, fairness, transparency are core engineering problems. We need to build for trust as a primary quality attribute. And today you'll be hearing a little bit more about how we can put security and fairness and governance in our systems.
Engineer practice still matters, if not more. AI generates, but it does not guarantee. In today's world, so customer experience will not become lower just because we are using AI to build the product and the system. It will only get higher. So customer experience still matters. Performance and reliability still matters. Security still matters. Good software still needs testability, observability, and modularity. So Gen AI really amplifies the status quo. So if you're good today, so it actually will get better. If you are bad, like your current state is bad, you will get worse much faster. So when everything moves at lightning speed today, good engineering practice is the safety net to give you that fast feedback loop. So yes, the physics are changing, the tools are learning, but the constant remains judgment, system thinking, our craft, and adaptability. So AI bends our gravity, but does not erase it. So the center still holds. And now the question actually becomes, how do we explore from here?
We began this morning with a rocket launch, the symbol of discovery and defiance. But every mission eventually leaves the launch pad behind. The question is, once we're out in orbit, how do we navigate? There's no flight plan for what comes next. The maps we've relied on, the methodologies, frameworks, playbooks, they don't chart this terrain anymore. We are all explorers now. In the next 3 to 5 years, AI won't just assist our work, it will reshape the environment we build in. Software will become increasingly self-writing, self-testing, self-evolving. The feedback loops will be tighter, the abstractions higher, the interfaces more human. But this future won't be built by algorithms alone. It will be built by engineers who choose to explore the edge responsibly. to push forward without losing sight of what matters.
So this morning we actually have explored around the gravitational shift. We're talking about a building for intent. We're talking about the collapse of cost and time and the rising of expert generalists. We also explored that actually well gravity still holds, system thinking over tools, AI in the loop, and engineering practice still matter. With everything here, and for us as an engineer, a technologist, we're all explorer here. It's our responsibility to define what software will be and how do we build and deliver software to expand and to evolve.
So as you spend the rest of the day hearing stories of what's real now, remember the horizon is just ahead. The next 3 to 5 years will test our craft, our ethics, and our imagination. Let's treat this era not as a threat to our expertise, but as an expansion to it. Let's be the generation of engineers who learned to not just build faster, but to build wisely. Gravity still holds, but the horizon has moved. Let's go explore together and let's see what's out there.